Okay, so part 2 here of our review. We're starting at 6.111 here. We did this one yesterday as a day op. So it was due yesterday, but I wanted to go over it just to double check that you're on the same page with me. You want to write it in radical form first. Okay, we're allowed to use calculators on the test, which means you could plug that right into a calculator and get an answer. But I really want to see the radical form first. So your radical form would be cube root of 8 to the first power. Now, since it's the first power, it doesn't make a huge difference. We could just say it's cube root of 8. And then the question is, what number times itself 3 times gives you 8? That's what that's asking. So that's basically x times x times x equals 8, which is 2. You're done. On B, it's same idea. I want to see radical form first. So you do the 5th root of 32 squared. Okay, now we can actually move this square to the outside because the 5th root of 32 is doable. The 5th root of 32 is asking what number times itself 5 times gives you 32. These are all going to be whole numbers tomorrow. They're all going to be whole numbers. So we can kind of guess and check. Well, 1 doesn't work. 1 times itself 5 times is just 1. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So it's, again, 2. But we got to square it still. So the answer is 4. And same idea with the 125. That would be the cube root of 125. And again, hopefully you're learning that you could take that 4 and put it underneath or on the outside, like we did here. I put the 4 on the outside. The cube root of 125 is what? What times itself 3 times gives you 125? 5. 5 times 5 times 5 is 125. So the answer here is 5, and then you get raised to the 4th power. Might need a calculator for that. That is 625. Very imperative that you show all your work. I will be marking down for not showing work, and I'll give you partial credit for showing work. So make sure that you show all that work tomorrow. All right, 112. 112, you got to use these methods. Quadratic formula, factoring, completing the square, and graphing. Okay, each one of them has a different way to show the work. Quadratic formula is x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So what is our a, b, and c right here? A is 3. What's B? 4. You don't need the x part on there. And C is negative 7. Make sure it's negative. So put that over here. X equals negative 4 plus or minus square root 4 squared minus 4 times 3 times negative 7. I got to see this because a lot of you, I should say a lot of you, but some of you will enter that in the calculator wrong. Or you put it in the wrong order. So I want to make sure that you get that, those points for showing that you know how to at least enter it into the quadratic formula correctly. Oops. So now, negative 4 plus or minus square root 16 is 4 squared. Let's see, that would be, 21 times 4, which is 84. And then there's a negative and a negative, which makes it positive. So plus 84 all over 6. So that would be negative 4 plus or minus square root, it's 100, over 6. Negative 4 plus or minus 10 over 6. So now your two answers. Negative 4 plus 10 is 6. Divided by 6 is 1. Negative 4 minus 10 is negative 14 over 6 is negative 14 over 6, which is negative 7/3. You could have that in decimal form. At some point here, you could type it in your calculator and get in decimal form. If you give me this right here, the quadratic formula part, and then give me the wrong answer, you'll get some partial credit. At least you just typed it in the calculator wrong. You don't have to go through every one of these steps, but I gotta see at least this step, and I would recommend this one and this one. The rest would be calculator work. Factoring. That is the box area model. So this is B. So go here. We got x squared and negative 18. Diamond problem. Negative 18x squared. Oh, what goes on the bottom here? Negative 3. Negative 3x. So what multiplies to 18? 6 and 3, and it adds to negative 3. So if I got 6x and 3x, which one of these is going to be negative? The 6, they give us a negative 3x. So let's go negative 6x and 3x. X times x is x squared. This will be a negative 6 down here, and this would be a positive 3 right there.
Does it matter if you switch the negative x? Negative 6 and 3.
No, these two, no, won't matter. It'll just, the negative 6 will end up here and the 3 will end up down there. Just be careful because this isn't finished yet. When you factor, it's not quite finished. We have to solve that. So what does x equal now? Negative 3 and 6. We set each of those equal to 0. Again, this should be kind of a review. We've done this last semester and before, so you should have a lot of notes on that. All right, C. Completing the square. X squared plus 4x plus 1 equals 0. This is where you have the square. You fill it in with the little squares. Thank you. So this is where you go. That's my x squared tile. I got 4 x's, so I'm going to divide that in half. Put an x here, 2 x's to the right, and 2 x's on top. This 1 is just going to go right here. So how many little squares do I need to complete the square? 3. Got to add 3 here. So that means I'm going to add 3 and add 3. I end up with x squared plus 4x plus 4 equals 3. Now I look at what the dimension here is. What's this length here going to be? X plus 2. And it's a square now, so it's x plus 2 squared. So we can go x plus 2 squared equals 3. A lot of partial credit throughout this one. Okay, now how do we finish solving that for x? I got an x plus 2 squared. What do I want to get rid of here? The squared, so what do I do? Square root both sides. So I got x plus 2 equals root 3. That's going to be plus or minus root 3. Subtract 2 from both sides. X equals negative 2 plus or minus root 3. And you can leave it just like that. If you really wanted to find a decimal answer, you can type that into a calculator. Negative 2 plus root 3, get a number. Negative 2 minus root 3, get a number. But you leave it like that, you're good. Bryce?
For the test, do we have to do it different ways, or can we all
Different ways. Different ways. Now I'm not telling. Here's one thing I won't tell you, or a little secret. If you're really good at doing it one way, quadratic form, do it on scratch paper. Get your answer. Start showing some partial work. If you get the answer and you show some good work, you'll get most credit. You know what I mean? If I can tell that you didn't use that way, then maybe you get a 4 out of 5 if you have the right answer and show some work. I just want to see that you know kind of how to get it started in each structure. Okay, graphing is the easiest. It's also the hardest to show the most work. So for graphing here, you can actually enter right in your graphing calculator and then sketch it on your paper. Oops, let's draw a little line right here. Let's turn that on. Okay, so I'm just going to go to y equals here. 2x squared plus 5x minus 12. And we want to see where that equals 0. Okay, so we're looking at for where it crosses the x-axis. I'm going to go zoom standard because we had our standard window right there. Okay, now I can do a quick sketch over here. Let's try this here. So I'm going to do a quick sketch. And if I look really closely here, I can see it hits somewhere around 1.5. That's the point I really need. And then it hits somewhere around 4, it looks like. And then we can draw that sketch. Put some labeling there. And that's what I would want to see in your paper. Now you definitely got to show where those points cross. I don't know for sure, but if I go to my second table, oh, I started way high yesterday because we were working on that one problem. Scroll back up to a reasonable number here. Almost there. All right, so there's one right there. I can see negative 4, 0. So this is definitely negative 4, 0. So x equals negative 4 is one answer. And my guess is that's 1.5. Now here's how you can check. If I look at my values here, it definitely crosses between 1 and 2. Okay, so what I can do is I can go second calc value and just enter in 1.5 and check it. And you see it crosses at 0. So it is at 1.5 comma 0. So that's your other answer. So that's what you would need for full credit on your test. Sketch those points of intersection on the roots are on the x-axis, and a label. I think that's probably the hardest question on the test. I think so. I mean, it's a lot of quadratics. It's older stuff. I mean, I think the special right triangles is pretty easy from yesterday, as long as you have those. Maybe that fencing problem that we did, but we've worked on that recently. That seemed not to be too bad. Okay, I got one more here. Oh, sorry, I got two more here. Eyes. So if there's a plus or a minus, we just add or subtract them. So here, we just add the real numbers. 3 plus 7 is 10. Add the imaginary numbers. 4 and negative 2i is just 2i. Done. That's your answer. No. That is PEMDAS. I mean, there's nothing other than adding and subtracting, so you just go left to right there. Now, B and C, for that matter, they have some, multiplying here, which makes it a little bit more difficult. This is squared, so we're going to have to square it and then distribute, which is like FOIL, if you guys learned FOIL. So the first one is 3 times 3, which is 9. 3 times 5i is a plus 15i. 5i times 3 is another 15i. And then 5i times 5i is 25i squared. Huh? You just multiply everything by everything. So you're just taking and you're multiplying, first times the first, outside. So if you haven't done this before, FOIL is first, outside, inside, and the last two. That's where the FOIL comes from if you learn FOIL. Usually they say distribute. Okay, now we can combine the i's, but the only thing here is I squared equals -1. So I squared is -1. So what we end up with here is 9, and then that's a -25. 15i and 15i is a 30i. So remember, you can't combine the i's and the numbers, but if there's an I squared, it's -1. And then 9 and -25 is -16. So it's -16 plus 30i. Final answer. So basically, treat it like an x. Treat the I like an x when you distribute, multiply, add, all that kind of stuff. And if it's an I squared, you just make it a -1 instead.
Why can't I just use an x?
You can use x if you want. Just x's don't usually, they're variables, and I is a special variable for that square root of -1. Okay, same thing here. It's the exact same thing. We're going to distribute first. 7 times 7. 49. Outside, 7 times -i. -7i. Inside, 7 times I. 7i. Last, I times -i. The -i squared. The nice thing here is, what do you see canceling out of there?
7.
These 7, the -7i and the +7i are going to cancel.
Where do you get the square?
The squared? I times I is I squared. So now we get 49 minus, but I squared is -1.
48.
Other way. 49 minus -1 is a 50. It's 49 plus 1. Okay, again, show all your work. If you make a little, algebraic mistake here, you'll get partial credit. Okay, if you don't show your work and get a wrong answer, you'll get 0 credit. All right, last one on D here. This, you have to use PEMDAS here. So your exponent comes first. So that would be 4i squared. That's going to be times 3i. Now I squared is -1, so that would be actually 4 times -1, which is -4, times 3i, which is going to be -12i. To shorten this test up, I probably won't have 4 of these i's. I'll probably have 3.
Good.
Okay, now last question. I'm changing it up from what was on the tests or what was on the test review in the book. Okay, you got to draw. This is what we did last semester and start this semester. So I want you to draw the special right triangles for this. So special right triangle. This one is a 30-degree angle. So we're going to use a 30, 60, 90 right triangle. So the triangle we're going to use, got to draw it out. You don't draw it, you lose points. You just draw it 30, 60, 90. And you call the shortest side 1. If the shortest side's 1 on the 30, 60, 90, what's the longest side going to be? No, not 2. It's double. And what about the middle side here? 1 square root 3, or just root 3. Every 30, 60, 90 will look like that. That's the basic 30, 60, 90 right triangle. Okay? And then all you do is, while we're at that, sine 30, here's 30. Sine is opposite over hypotenuse. So what's the opposite side from 30? 1. And the hypotenuse? 2. That's it. That is it. All right. And let's try the same thing for cosine 45. So now we draw 45, 45, 90. That was not a good one. It's all right. Call the short side 1. What's the other side here? No? That's 1. It's 1. It's the same. It's an isosceles right triangle. And then what's the hypotenuse going to be? Square root 2. Okay. So now cosine is, what's the ratio for cosine? Adjacent over hypotenuse. 45, the adjacent side is 1. The hypotenuse is square root 2. And I'll let you leave it like that. Usually you get that square root out of there, but I'm more concerned with just using the ratios right now. And that's it. That's your whole test review.